So let's look at a basic negative feedback system from a controls perspective, and then we'll tie it into what it means for an operational amplifier. So from a controls perspective, we often do something called perturbation analysis if we want to determine if a feedback is negative or positive. So here we take a signal input, we feed it into a summation block, we give it some forward gain, little a, and we come to an output. So here's our input, here's our output. Now we take a sample of some of that system, that output, we feed it back to the summation block, but we give it a minus sign. Now let's check to see if our system has negative feedback. If we put a plus delta SI at the input, we see that our output, we get a plus delta S out. It's equal to A times whatever that input perturbation is. Now some of this signal is fed back to the input via this negative summation block, so we get a plus delta SF, or S feedback, but we're subtracting that plus delta SF from the input. And so the negative sign causes the output to fight the input. So we do have negative feedback. Alright, so let's calculate the gain of our system. So let's look again at our feedback system, and I'll draw it really quickly. Same system that we were just looking at. Alright. So we know that the input to the amplifier we're going to label as S2, and we know that the output of this beta block is going to equal to beta times S out. Alright, so we know that S out is equal to A times S2, and we know that S2 is equal to SI, the input, minus beta times S out. So if we make substitutions, we can find that S out is equal to A times S in minus beta times S out. And rearranging, we can write an expression for gain. S out divided by S in is equal to A divided by 1 plus A times beta. Now a couple of things here fall out. We call the term beta our feedback factor. And the term A times beta is defined as our loop gain. Alright, now remember, for an ideal voltage amplifier, which would be our A term here, we'd like A to be infinite. And if A is infinite, so if we took a limit as A goes to infinity for our gain expression, we would see that S out over S in would approach 1 divided by beta. In other words, our gain only depends upon our feedback factor if the operational amplifier or the voltage amplifier's gain is infinite. And the nice thing is that what this means is that our output is always finite assuming that our feedback is finite. So we have an amplifier that has ideally infinite gain, and when we put it in a negative feedback system, we get a gain that's finite. And what we're going to find out is that it's finite and it depends upon usually a ratio of some resistors. Now, you've all seen a feedback system already. Probably the most common feedback system that you might see is an inverting operational amplifier. So here we have a resistance R1. We have an input voltage going into this one side of the resistor. We ground the non-inverting terminal of the operational amplifier, and we feed back from the output through a resistance, R2. Okay, so here's our amplifier, and we know very well that the expression for our voltage gain is V out over V in for this type of system is equal to minus R2 divided by R1. And we also know that this should equal something like 1 over beta. So here we know that beta is equal to R1 divided by R2. Or I should say minus R1 divided by R2. So to summarize, negative feedback ensures a finite output, regardless of what the gain of our amplifier is. Typically, what we're going to find is that the gain of our entire feedback system only depends on external components. And specifically, typically it depends on the ratio of external components, which is going to help us when we try and make systems over process variations. And 3, and this is maybe the most important point, when we design amplifiers with transistors, it's very easy to get large gain. So we'll say easy to get large gain. But it's not easy to get precise gain with the transistors. This shows us a way that we can get a relatively precise gain leveraging the fact that we can get very, very large approaching infinite gains with transistors. So our gain is going to be dependent upon that ratio of components rather than the absolute gain of the transistor amplifier, and this is something that we use almost every day in our lives.